I've got to use logarithms to solve this equation. So I need to use logarithms to solve it. So if I've got a calculator which will work in logs to different bases, I can just do the inverse operation of 5 to the power of a number, and that means I would log it to the base 5. And that's the inverse operation of raising 5 to that power. So that will actually vaporize the 5 and just leaving x minus 1 equals log to the base 5 of 120. So x minus 1 equals, type that exactly into a calculator, 2.9746, and so x equals 3.9746, or x equals 3.97 to 3 significant figures as asked. But if your calculator won't work to log to base 5, you're going to have to do it this way, and lots of calculators don't. You're going to have to log it to base 10. So you'll get log of 5 to the x minus 1 equals log of 120. You don't really need to put the tens in, because if they're not there, you assume they're not there, that there's 10. So this bit, laws of logs, I can bring the x minus 1 down. So x minus 1, put it in brackets, because all of that is times by log of 5, and that equals log of 120. So I'm going to divide both sides by log 5, and that gives me log 120 over log 5. And so x minus 1 equals 2.9746, and so x equals 3.9746, etc. And then we get 3.97 to 3 significant figures. Part B. And when we have part B, it normally doesn't refer to the previous bit. I've got to solve this, log to the base 2 of x plus 2 log to the base 2 of 3 equals log to the base 2 of x plus 5. And now we want to get rid of the word log, so that means we're going to have to raise it to the power of 2, so I'm going to 2 it. But unfortunately, at the moment, I've got two things here. If I'm going to do the inverse of the operation, I want to have just the one log, so I'm going to have to put this together to make it just one log. That 2 goes up to here. So the first thing, we get log to base 2 of x plus log to base 2 of 9, because that's 3 squared, equals the right-hand side. And now we've got a log of a number plus log of another, and so that is the same as the log of the product. So x times 9, or 9x, equals log to base 2 of x plus 5. And now we can 2 it. And 2 it, well, it's the inverse operation of this. So as soon as I raise 2 to the power of this, the 2 to the power of and log to the base 2 will sort of vaporize each other and just leave us with 9x. And similarly over here, that will vaporize that and leave us with x plus 5. Take away x from both sides, so 8x equals 5, and so x equals 5/8. And that's question 4 done.